So the original title for this presentation was Multi-Tenant Kubernetes, and I'm going to get to that at the end because I'm from Hyper. My name's James Kulina. I'm actually the Chief Operating Officer, so I'm more of the business guy. So unfortunately, I'm supposed to have a co-presenter today, our CTO. So if you have very technical questions, please come see me afterwards. I'll make sure to get those answered for you. But what is Hyper? So we are a startup. We started last year, middle of last year, and we are focused on making VMs, virtual machines, run and look and feel like containers. And so you're probably asking yourself, well, why even do that? And I like to take a look at where we came from the IT perspective to where we're going now. Kubernetes is an enabler for container as a service, right? So the agenda here is CAS, like how do we actually get here? What, the route that we took, all the different technologies that we've seen in the last 10 years, 15 years. The end goal, what's our end goal with actually using Kubernetes and container as a service? Then I'm going to get into how it's actually implemented today, how are people actually deploying Kubernetes to enable this. What is Hyper? What do we actually do? What do we create? How Hyper works? And our vision of next generation container as a service, and our Hypernetes. That's what we call our multi-tenant Kubernetes distro. So how did we get here? You know, it really first started off with virtualization, right? With hypervisors. And what was the whole point of that? It was a business, it was an economic reason. It was taking the large number of servers and saying, I need to do all of this, but on less of them. I can save money and allowed higher utilization. That was the whole purpose of hypervisors. And this has served us very well, actually, in the last 15 years, and it's been mature, it's battle-tested, and it's trusted, more importantly. The next thing was, okay, well, that's great, but everything's manual still. So how do I automate this thing? How do I accelerate what I'm actually doing for IT services? How do I enable my developers, right? And so that's what infrastructure as a service was supposed to help with, was actually the automation piece. We can actually say the data centers now, you can use infrastructure as code. But we're still talking about servers here. We're still handing out servers to developers. So it's not actually as efficient as developers really wanted. They wanted a different abstraction. And so they were like, okay, well, PaaS, like that'll solve the problem. Platform as a service. So we're focusing entirely on the app. We abstract away all the infra. And that was great. People ate it up, but there was a big problem with it, right? You couldn't move your app from one platform to another, right? They made very strong, opinionated decisions on what you could do and what you couldn't do. And then something else came out, and that was Docker. So Docker solved a lot of the problems of app portability, right? It was all about packaging. It was all about how to make my app move around, and so I'm not locked in. It did nothing about security, right? If you actually look at it. But it did provide immutability, right? So no moving parts within your app, within the infrastructure. So what's the end goal today of container as a service? Because that's where everything's going, right? So the end goal is we have to keep in mind that we need to enable value creation. Right? If I talk to a CFO, if I talk to a CIO, he's going to say, my boss, the CEO, gave me a directive saying we have to hit these numbers, we have to grow the top line. How are we going to enable to do that? How are we going to do that as you are the support structure for us, right? And so this is what we really have to keep in mind when we say we're generating a new type of platform, a container as a service. We need to keep this in mind of accelerating app development and providing the tools so that the developers, self-service, don't have to rely on ops. We also have to ensure security, right? So we need to make sure that what we've developed in the last 15 years doesn't just get thrown out the door because there's a new way of doing things. And so I would say that we have to at least have the level of security that traditional virtualization provides. And we have to reduce risk, right? So app portability, Docker really helped with this. You can move your app from one cloud to another. You can run it on different infrastructures. You can run on any Linux distro you want, right? The multi-cloud strategy, you see this, RightScale had a report last month saying that more and more companies are using 1.8 clouds, right, per company. They have a multi-cloud strategy. They don't want to get locked into one cloud, and they view it as deleveraging their risk. And so lowering costs, this is always going to be there, right? You have to be able to say, by adopting this platform, you're going to move faster, you're going to eliminate the cost on the bottom line, right? You're going to reduce it. And so we have to minimize ops. And so right now, the way we see container as a service today. So this is your typical COE. So that's Kubernetes up there, right? And you have your VMs and you have your containers running inside. All of this sits on top of infrastructure as a service. And you're using, say, AWS, typical deployment. We see two problems at Hyper with this scenario. First one is you have to create VM pools, right? I have to already do capacity planning. What is the actual instance types I'm going to require for my containers? What's the storage setup? What's the VPC setup? The SDN setup? So if I'm already doing all that, and I'm already saying that I'm going to have different types of instance types, right? So for instance, say I have a DB container, and I have a web container. Well, the DB container might need more memory and disk space, where the web container might need more CPU. So now I'm already basically saying these are going to match up. So I'm already scheduling. I already know where the result of the scheduling is going to happen. So why do I have another scheduler on top of this? Why would I just say this instance type maps to this type of container, right? So if you're already creating VM pools, you know for a fact you're going to have low utilization overall. It doesn't matter how good your scheduler is. There's going to be idle resources. And the second problem is that you basically just have two management planes you now have. You have Kubernetes, and you have your infrastructure, right? You still need to manage the infrastructure. You still need to manage all these instances. The SDN, the storage, how is it set up? How's it run? You need to manage the applications, which is containers now. Orchestration, self-service. Kubernetes helps with this, but you still have to manage Kubernetes. And this leads to other things, like nesting, right? You nesting your SDN, your VM, your container SDNs and your VM VPCs, right? Incredibly hard to build, maintain, and especially debug. And what about storage, right? So if I'm loading this on AWS, how do you do persistent volumes with containers? Well, you already have EBS volumes on AWS, but now I have to use Flocker on top of that, right? So another layer of complexity that you're adding to this. So what is Hyper? So we are a hypervisor agnostic Docker runtime. This is where we started. We basically, our Hyper container is the base unit, and this is running your Docker image directly on hypervisors. So you can run any Docker image on, we support open source hypervisors. We support KVM, Xen, VirtualBox, and we're actually working on ESX. Here is the screenshot of how to actually launch a Hyper container. And so it's the same, we've mapped our CLI and our commands directly to Docker. And so you pull it, you run it, but instead of running or launching a typical Linux container, you're launching that. You're launching basically a very stripped down VM. That's the very lightweight. And so you get the security as virtual machines, and this thing is very fast. So we can launch a Hyper container in 200 or 300 milliseconds. Right? So how does actually this work? So the white is the host server. These down here below are the Docker images. So you pull them actually onto the physical host. Then we have, in the Hyper container itself, which is the gray box, we have what's called the Hyper kernel. And it's an optimized Linux kernel. Very lightweight. And we have no guest OS in our VMs, in our Hyper containers. And so the Hyper kernel will start this HyperStart, which is our micro init service. And the purpose of that is to actually load your Docker images into the Hyper container. And we designed this Hyper container actually with pods in mind to begin with. So it actually maps very well to Kubernetes. And then we use mount namespaces to isolate your different images so they can't see each other's rootfs.
So just to be clear, this picture has one pod in a Hyper container. Is it always exactly one?
One pod? No, you can have multiple pods.
Okay, thank you.
So what we're trying to deliver is the best of both worlds here, right? So you have isolation. This is just a comparison between VMs, our Hyper containers, and traditional containers, right? You have traditional containers with shared kernel, right? So weak isolation. We're using hardware enforced isolation, hypervisors. We have portability, right? We support multiple hypervisors, and we're basically a Docker image. So you can take your Docker image from your hub, your repo, whatever, and we can actually run it on different platforms. Boot time, right? So VMs, minutes in boot times, where containers are incredibly fast, and we're just a little bit slower, but still very fast, sub-seconds. Image size, we're still container level image size. Our actual Hyper container is about 25 megabytes. Compared that to VMs, which is multiple gigabytes, tens of gigabytes. And immutable, right? It's just a Docker image that we're running inside. So we're just as immutable as a traditional Linux container. There's no moving parts. Whereas a VM, you actually have to manage the guest operating system, right? Which spawned an entire ecosystem of configuration management. And then compatibility. So this is more about the tool chains of managing it. So VMs, right, they have lots of very mature tool chains to manage the infrastructure. Containers, we're getting there, right? It's not as mature. You can't reuse anything that you're using for your VMs to be managing containers, really. We have some overlap compared to that. Maturity, same thing, right? So infrastructure as a service and VMs been around for a long time. They've been developed, matured. We're using Hypervisor technology, which is very trusted and mature. And then bring your own kernel, and this is very important, obviously, for public cloud. You need to allow tenants the ability to select their own kernel and kernel modules to run. And so you can do that in VMs, you can also do that here. And then ROI. So this is referring to the fact that, okay, for the last 5 years, I've been hearing about OpenStack. I've been building out my own OpenStack. Now you want me to throw it out and start all over with containers, right? So with Hyper containers and Hyper, we're saying no. In an OpenStack environment, you would replace Nova, which is used to manage VMs, with Hyper. And now you have a container as a service solution. All the interfaces, because it's a VM, are the same, so you can connect to everything. So this is what the public cloud cast looks like right now. And what we're proposing is something more like this. We're moving Kubernetes down to the foundational layer. This is the orchestration, this is the management. Hyper containers are being launched on demand from that. There's only one layer, it's not two layers. And so that's what we created with Hypernetes. So we're using components of OpenStack because the software interfaces make sense, right? They're mature too. So we have Cinder Ceph storage, we have Neutron for SDN, but we're using Hyper as the runtime. And so instead of launching your traditional VMs, you're launching Hyper containers. And it's all being managed now by Kubernetes. And so you get the isolation from the hypervisor, but you get the container performance. So all of this is actually open source. So we're an open source company. We're open source capitalists. If something comes along that we like and that we can use, we're going to do it. So there's our website, Kubernetes, get docs and GitHub. And the one thing that I'd like to talk to you guys about as well is that at the end of this month, we're actually launching our public cloud version, where we're using Kubernetes. But we took a little bit of a different stance here. So it's a Docker workflow. You have Docker native workflow for this. The way it works is you actually download the CLI on your laptop. And just like you would with Docker, you start launching containers. But instead of launching containers on your laptop, you're launching containers on our cloud. You get secure as virtual machines with this, right? Fully isolated, hardware isolation. It's hyper elastic. So sub-second boot times, and also you're not over provisioning. You don't have to create VM pools. Everything is on demand. It's just enough cloud. You get persistent storage out of the box, right? So you can have stateful workloads. And we have replication. It's distributed, redundant. You can do snapshots. And we're doing pay per second. So you actually use what you need, and your application can dictate what that is, right? You're not going to overpay. You're not going to over-provision. So you can sign up, actually. We just launched this today. And the private beta will start at the end of the month. We're looking to go GA later this spring. And also we have a referral program. So if you get into the private beta, refer some of your friends, and you'll get credits, and they'll get credits. Everyone's happy. So that's what we're really excited about. We're excited about taking the container as a service and making it truly easy to use, efficient, cost-saving. Yeah, so that's it. Any questions?
Yeah, so I'm a little bit lost. What's this going to do with Kubernetes? Looks like.
We're using Kubernetes to manage everything, to manage orchestration.
So Kubernetes has a networking, they call it a model, but it's a set of functional requirements that everything can talk to everything, more or less. How do you make that secure in multi-tenant?
The networking piece?
Yeah.
We're using Neutron's networking.
What are you doing with the Neutron networking?
All of our hyper containers are using Neutron's SDN for the networking piece. So
there's a lot of different things you can do with Neutron, but as soon as you use Neutron to make everything talk to everything, you're back to the question of how you got your tenants isolated.
they're hardware isolated in pods and hardware virtualization isolated. So
right, the Kubernetes requires them to talk to each other.
Right, your specific pods, right, and your specific images inside your hypercontainer can talk to one another. It's on layer 2. They automatically see one another.
Right. And in Kubernetes, the hosts can talk to the containers. All the containers talk to all the containers. So my containers can talk to his containers.
No, so our hypercontainers are isolated from one another, right? So like your images, your Docker images are going into your hypercontainer. Within that, they can see one another. They cannot see his hypercontainer.
But I get more. Do I get only one hypercontainer? Or do I get many hypercontainers?
You can launch as many hypercontainers as you need.
And can my containers communicate between hypercontainers?
Yes, they can. Right. So
I guess one of my questions here is, so Kubernetes thinks it's managing pods. So I'm still
right,
confused.
but
Does a pod correspond to a hypercontainer, or are there many pods in a hypercontainer?
the hypercontainer is running. There's pods inside of hypercontainer. So Kubernetes is managing the hypercontainers.
But it thinks it's managing pods.
Right. There's no difference there. It's
Okay,
managing.
So it's one
yeah.
pod per hypercontainer.
You can, yes, we can do both, but yes, you can say that to make it easier, you can say one pod per hypercontainer.
I think for one makes sense. If if you have multi-pods in one hypercontainer, you need to build two overlay networks. Right.
Right. But right now, we have a pod that's the hypercontainer is the envelope around the pod, right? And so Kubernetes just thinks that it's managing pods, but it's managing the hypercontainer.
Okay, so if there's an equation between pod and hypercontainer, Kubernetes requires that all the pods can talk to each other. Equivalently, all the hypercontainers can talk to each other. So where's the isolation between tenants?
So that's a question I'll get to my CTO. But yeah.
I think that maybe how it would work is that what you're saying is that the isolation is, instead of being at the OS level, it's at the hypervisor level.
Yeah.
So it creates a virtualized OS through their hyper.
You're creating your own VPC.
Provides a deeper isolation than what you would if you were running different pods in the same OS. So I think that's what they're calling a multi-tenant Kubernetes, because it's just a safer way to run pods in a smaller version of the OS, that it's just this hypercontainer. I guess that's how I understood it. But
Well, I'm focusing on the networking here, which is not limited to one hypercontainer.
correct.
So when we're talking about multiple hypercontainers, we're talking about the networking.
That was my same question. Is like,
Basically, Kubernetes is single tenant application. So how do you encode multi-tenancy? How do you tell the pod to be started by different, to belong to different tenant?
Or rich tenant.
Right.
One rich tenant.
that was my question as well. So it seems like the multi-tenancy stops really at, right now, isolating pods into your hypercontainers, but still everything around it, the networking, the rest of the layers, are not really multi-tenant, or maybe there is something else, but that's, I think, where the questions come in. Is there anything else on top of Hyper or whatever that it's actually causing part of that isolation between maybe my containers and somebody else's containers? And further, within your cloud, how are you guys addressing that? Say I sign up for your cloud and deploy a bunch of containers, and somebody else signs up on your cloud and deploys a bunch of containers. What's to prevent my containers to communicating, discovering, seeing, or reaching somebody else's containers, and how are you addressing?
Right, so every tenant basically gets their own VPC on the hypervisor. Right, we're using isolation, the hypervisor isolation, and the networking piece from Neutron to actually do the isolation of the network, and so that they can't see your L2 network.
So if I understand you correctly, say when I register on your public cloud, you will create a separate Kubernetes instance, like instance of Kubernetes for me.
Yeah.
So that is where tenancy. Each Kubernetes installation is single tenant, but you would have a Kubernetes installation per tenant.
I didn't hear that at all.
Well,
Is that what you're saying?
You have to work it out.
Yeah.
So is there one Kubernetes API server, or are there many? One for each tenant?
No, we would be producing multiple Kubernetes API servers. So
One for each tenant?
for tenants.
One for
Right.
each tenant? That's it.
Right.
Well, that's part of it. That doesn't answer the networking question, though. Because,
So come talk to me afterward, because
okay.
I'm the business guy.
Okay.
So we're still very new, but we think we're onto something here, right? So I don't know if you've ever heard of other that are trying to do this. It's called Intel and Microsoft, right? Yeah, with clear containers. And when Microsoft's with their Server 2016 and Hyper-V containers. It's the same idea. It's using hypervisor for isolation, right? So you're not sharing a kernel. Every hypercontainer gets their own. Yeah.
I had another question. How does it compare to unikernels? I guess, was it parallel on that?
Yeah. Well, unikernels aren't, I'm not too familiar with how they're actually operating, but I mean, the whole point is that they're actually still sharing kernels, but you're actually isolating, through, there's a different way that they're actually doing isolation, but they're packaging it in a full thing that you can't actually separate across. So there's something that we've looked at unit kernels as well, but we ruled it out.
So is this an open source project?
All of it's open source. Yeah.
You're actually posting all of this, we've been asking everyone to come and do the private beta and give you feedback?
Oh yeah.
That's what you want, right?
So yeah, we want the private beta, and it's free. So anyone can sign up and beat the crap out of it, you know, just take it for a spin. And yeah, go to our site and you'll be able to download Hypernetes, you'll be able to download our underlying technology, and play around with it. You can run it on your laptop, right, VirtualBox.
Can I run it in Zen VMs?
Yeah.
Zen VMs.
We support KVMs and VirtualBox.
You said KVM and VirtualBox.
And Zen,
In Zen.
yeah.
So you're not actually hosting it and letting us play with it? We have to install it ourselves?
No. This is hosted.
This is the host.
That's the
got it,
hosting.
okay.
Right, but you can download all the other, I mean, you can go to our GitHub account, download everything, play around with it.
So what are the resource limitations with what you offer? Like, how much capacity would you give a beta user?
For the beta user, we're still debating. Right now, we have it kind of open. So yeah. We actually kind of want to see people break it, like
Do you
take
have
it.
a dashboard or a way to monitor
Yep.
what I've used?
Yep. So.
Are you able to actually show us?
Unfortunately not right now. Yeah. So it's actually going to be launching at the end of this month, but we're going to go through and because we want to limit the amount of people on the platform just so that they don't one person doesn't take too much advantage of it. But yep.
I have a question. You're now using Kubernetes to manage hyper runtime, right?
I'm sorry, we're not.
You are using Kubernetes to start a hyper container, right?
Mm-hmm.
So is it done in Hypernet or have you already upstreamed it to Kubernetes?
So we are upstreaming the Hypernetes work that we've done to Kubernetes. Yeah. So we were waiting for 1.2 to hit for us to. There were some things we had to work out, and now we're upstreaming all of that.
So it's in progress, but not finished yet.
What, the Hypernetes?
I
Or-
mean upstream work.
No, the upstream work. I mean, it has to be accepted, right? Yeah. So,
Any
Thank
other
you.
questions? Did everybody just sign up?
I have one last question. So, does it require, I guess, a modified version of Kubernetes to manage hyper containers? Or
it's standard. It's Kubernetes. You can, yeah.
Well, standard Kubernetes launches Docker or Rocket containers. It doesn't launch kernels or hypervisors.
Right, but we've plugged in our runtime into it. So on the hypervisor. So yeah, it's sitting on top of our the OpenStack components, right?
Also the same problem with fake Docker command.
Huh?
Are you faking Docker command or how do you make Kubernetes aware of Hyper?
I'll have to ask. I'm not entirely sure the actual mechanism.
Okay, I have another question. So the Docker command line, you said you got the Docker command line. It has things that assume that the guy launching a Docker container is the owner of the host. How does that work in your public cloud? I mean, when I run a Docker container, I can say what host port to map things to.
Mm-hmm.
Right? If you and I both ask to map to the same host port, well, we don't even know what your hosts are, and how are we going to avoid port conflicts?
Right. These are all the good questions. I don't think I'm the right person though for right now. Let me, I'll jot them down. Let me get your contact info and we'll get you connected to my CTO. So I apologize he wasn't here today.
Which Kubernetes version you were using?
We're using, this is why we're waiting on 1.2 because we're actually going to be using 1.2 for this, for the public